Hey everybody, welcome back. Hope you're having a wonderful Friday morning or afternoon, whenever you're deciding to watch this video. Once again, make sure you have this document either downloaded as a PDF. You can use the Cami app, or you can use your notes. You can write on a sheet of paper. You can do whatever you would like. It's up to your call. But have something to write on so you're not just watching it and you can have it another day. So what we're going to talk about here, exponent properties and converting forms. We're going to start with just basic fractions. A lot of it goes the same. Remember, when you're adding fractions, you must have a common denominator. So I'm going to go ahead and write that over here for you. So a common denominator. So if I have a 9 and a 6, a good common denominator, two numbers that go together with 9 and 6, most likely is going to be 18. So to get a common denominator over here, I'm going to multiply the 9 times the 2. What you do at the bottom, always got to do the top. 6 times 3, so times 3 times 3. So that's going to give you 2 over 18 plus 3 over 18. You end up getting 5 over 18. Subtraction, same thing. Must have a common denominator. I'm just going to abbreviate this because it's above it. Same thing, 4 and 3. Good common denominator with 4 and 3 is 12. So I'm going to times this by 3. This one by 4. So I have 3 times 1 is 3 over 12 minus 8 over 12. You end up getting negative 5 over 12. Now, multiplying is a little bit different. So what you're going to do here, you're going to multiply across. You always do the top and the bottom. So 2x times 6y is going to give me a 12xy. And then 3 times 5 is 15. So if you want to come over here, change that note, you're multiplying top and bottom. You're multiplying across. I shouldn't have done that, but whatever. And then you always want to simplify. So here, if I got 12 over 15, they're both divided by 3. So you get 4xy over 5. That's your simplified solution. Now, if you also want to come back to the beginning, you can cross cancel. 3 and 6, I can reduce that to a 2, that to a 1. Now when you multiply, it's already reduced. Either way, however you like it. Divide, we're going to keep, change, flip. KFC, keep, change, flip. So keep the first one, that's a 5. Change it to multiplying instead of divide, flip it. So instead of 3 over 1, it becomes 1/3. And now you're at the problem above it. So 2 times 1 is 2. 5 times 3 is 15. You end up getting 2 over 15. Now, if I'm going too fast, please make sure you just pause it. You can rewind it. That's the perks of a video, which is nice. If you got questions, make sure you're finding me, you're talking to me. Now, remember your laws of exponents. When you multiply, you're going to add your exponents. So I'm multiplying, they both have the same base. So I'm going to add the exponents. So I got 2 plus 2/3. Remember, you're adding, you got to get a common denominator. So that is going to become, I'm going to multiply this by 3 over 3. So 6 over 3 plus 2 over 3. So I end up getting 8/3. So my answer here is going to be x to the 8/3 power. When you divide, you're going to subtract the exponents. Remember, it's top minus bottom. So we're going to do top minus bottom. So I got 1/2 minus 1/3. So if I get a common denominator of 6, that's 3/6 minus 2/6. So I get 1/6. And we're going to leave that as 2 to the 1/6 power. Your base is always going to stay the same. You're just dealing with exponents. Power of a power, you're going to multiply. So I got x to the 2 times 3 is 6 over y to the 2 times 3 is 30. 2 times 3 is not 30. 2 times 3 is 6. So the y is going to be 5 times 3, which is 15. So they're different bases, so now I cannot combine those. If they were the same base, I would go forward. All right, so a few more examples. All right, so now let's look at this next example. So I got the same base, we're dividing, so I want to subtract. So I got 1/3 minus 1/2 So in a sense, that's going to give us 2, 6 minus 3, 6. So I get negative 1/6. So I have 2 to the negative 1/6 power. If you have a negative exponent, I'm going to move it to the bottom. So if that's over 1, you're going to flip them. So 1 over 2, and your exponent becomes positive. So in a negative, you're going to flip the base, and you're going to make the exponent positive. Or you're going to remove the negative sign, however you want to call it. Now, parentheses, we're going to work our way from inside out. So inside, I want to see if there's anything I can simplify. So inside, I see right here, I'm adding the x's. So I got 6. I can go ahead and reduce the numbers now that I'm thinking about it. So 6 divided by 9, if I go ahead and draw my parentheses, you still have an exponent of 4. I'll touch that later. 6 divided by 9 reduces to 2/3. Now with my variables, I'm adding the x's because I'm multiplying, so 2 plus 5 is 7, so I got x to the 7th, it's positive, so it stays up top. My y's, I got a 3, and then that's a 1 if there's nothing there. I'm dividing, so I'm going to subtract those. So 3 minus 1 is 2. 2 is positive, it goes up top. Now I got a power, so I'm going to distribute that power and multiply everything. So 2 to the 4th power is 16. Numbers, you do the same. Exponent, 7 times 4 is 28. So x to the 28th power. 2 times 4 for the y is just 8. 3 to the 4th power is 81. So you end up getting this big long answer. So 16x to the 28th power, y to the 8th, all over 81. The last one's kind of easy. Anything raised to the 0 power is always 1. So you can keep that nice and simple for you. All right, like magic, I just jumped over to the next page, paused the video and got back to it. So kind of simplifying your exponent properties. Multiplying like bases mean you always add your exponents. Dividing like bases, you're always going to subtract your exponents. Raising a power to a power, you're going to multiply your exponents. Anything raised to the power of 0 is always 1. Nice and simple. A negative exponent, you're going to flip the base. So if it's negative up top, it goes to the bottom. If it's negative on bottom, it goes to the top. An exponent outside the parentheses, you're going to work your way inside out, applying all your principles. So if it's multiplying, you're going to add. If it's numbers, you're still going to do the same thing. All right, the last part, we're going to be converting from radical form to exponent form. So this is radical form right here on the left side. This is exponential form. So anything with radical form, it's got a radical sign. So we're going to imagine this is B and this is A. I'll do those different colors for you. So we'll call the B green, and the A is going to be yellow. So if I have it looking like this, there's a root and then your exponent underneath it. The A is always going to be the top, and then your B is going to be the bottom of your exponential fraction. So if I'm looking here, going to rewrite this, I'm going backwards of what our example looks like. So x to the 2/5 is going to be the square root. The denominator's on the outside, the numerator's on the inside. Same thing with B. The denominator's on the outside, the numerator's on the inside. The denominator's on the outside, the numerator's on the inside. That one's backwards. I just rewrote exactly. I got going. So this one's in radical, so let's switch it. So I got my z. The outside's your base, the inside is your numerator, so 2/3 c to the negative 5/3. So that's a negative exponent, so I'm going to go 1 over c to the 5/3 power to make it correct. Now evaluating, we're going to do the same thing. We're going to rewrite it and then simplify. So here, I got the square root, 25 raised to the 3rd power. Now, that right there, 25 to the 3rd power is going to be huge. So that can actually go on the outside. You can put it on the inside, or you can raise the whole thing to the power. Because here, the square root of 25 is 5. That's easier to do. 5 to the 3rd power is 125. So it can go inside, or it could go outside. So if you're looking at it up in the example, I could have the square root of x with whatever that is, b, and I could raise the whole thing to a. It's the same concept, just depending on how you like it. So here I got the cube root of 27. I know that, so I'm gonna raise everything to the second power. Cube root of 27 is 3, so 3 squared is 9. Now a negative on the outside, it's gonna stay, so I'm just gonna let it tag along. So I got the square root of 16. I know what that is, so I'm gonna go ahead and put the parentheses on the outside. So that gives me a negative 4 to the third power. 4 to the third power is 64. 4 times 4 is 16 times 4 is 64. So you end up getting negative 64. Now, if the parentheses are on the inside like this, it's got to stay inside. So I got the square root, the cubed root, negative 64, all squared. So I can take the cubed root of a negative. So we're good to go here. So that's going to give me negative 4 squared, and that's going to be positive 16. Now the last one, I can't reduce this fraction. I do have a negative exponent, so what that means is I'm going to flip it. So instead of 64 up top, I'm gonna have 25 up top, 64, and now I got a positive 3/2. So that negative just means flip the base. So I got the square root of 25 to the third power over the square root of 64 to the third power. So I got 5 over square root of 64 is 8. And you're gonna raise them all to the third power. So you end up getting 125 over 512. All right, let's jump down to the last page. So I'm gonna rewrite these. So here I'm gonna start with my parentheses. So I got the square root of a to the 5th. So remember, that's gonna be a to the 5/2 power, and it's all gonna get raised to the third power. So now I have created, a power of a power. So now I have a to the 15 over 2 power. All right, so looking at the next one, I got the square root of 4b squared to the third power. So I'm gonna go ahead and simplify what's under the square root. That's gonna give me the square root. 4 to the third power is 64. B squared is gonna give me b to 2 times 3 is 6 power. So now if I wanna break this up, I can take the square root of 64. The square root of 64 is 8. If I wanna break it down, I can use my factor tree. If you don't remember the factor tree, I'll be glad to work through that one time. Here, an easy trick with exponents, 2 goes into 6 3 times with none left over, so I can simplify it that way. If you have anything left over, it's gonna stay underneath your square root, just like we're gonna do in the next one. So I got 8 to the x to the 8 third power. So I'm gonna rewrite it in radical form. So remember, I got x to the 8th power, 3's in the bottom. So here, a kind of trick that is kind of nice, 3 goes into 8 twice. So I can take out an x squared, because that 2. 3 times 2 is 6, so I have 2 left over. So I got the cube root of x squared. That cube root's gonna stay there. That cubed root has to be bigger than your exponent. That's a way to check, make sure you're doing it correctly. So this one I'm gonna rewrite it. I got 8. I got the cube root of 8 raised to the 5th power. Now, I always wanna look here. Do I know the cube root of 8? I do. So I can rewrite it like this. So that's gonna give me 2 to the 5th power, which is 32. If you don't, you would have 8 to the 5th power, which is gonna be an enormous number. So I don't really wanna work through those. All right, these last few are just gonna simplify. So same base, I'm gonna add the exponents. So I have 5, 6 plus 1/4. A good common denominator here would be 12. So I'm gonna times this by 2, this by 3. So I got 10 over 12 plus 3 over 12, which is 13 over 12. So I'm gonna get y to the 13 over 12 power. I'm gonna leave it like that as a fractional exponent. I'm good. In radical form, remember here it's the base of 12 raised to the 13th power. So those are your 2 answers here. Here I wanna see if I can simplify. So I got 3/4 minus 1/2. I need a common denominator here, so I can times that by 2. So I got 3/4 minus 2/4. So I get m to the 1/4 raised to the 2/3. So now power of a power, 1/4 times 2/3, you get 2/12, which is 1/6. So I got m to the 1/6 power. If I'm gonna convert it to radical form, that is the cube, or the 6th root of m. So I got both answers here. This one right here, it's a lot harder to combine them out of radical form. So I wanna switch them. So at h to the 2/6, oops, that's bad, times h to the 1/3. Now I'm multiplying so I can add, so I got 2/6 plus 1/3. So that's the same thing as saying 2/6 plus 2/6. So I get 4/6, which is 2/3. So I got h to the 2/3 power, which is the cubed root of h squared. The last one, square root of x and x cubed. I can go x to the 1/2 over x to the 3rd power. I can subtract these. So 1/2 minus 3 over 1. Get a common denominator, so 1/2 minus 6 over 2, so you get -5 over 2. So that'd be x to the -5 over 2, or I would rewrite that as 1 over x to the 5 over 2 power. So I have that, and if I want to rewrite that in radical, I can keep the same thing. So I got a square root of x to the 5th, and it's in the denominator, so we're good to go. So take a few moments. I know I went kind of quick through this. Look at it. If you got questions, make sure you're asking me. Good luck on the practice. If you need help, shoot me an email, and I'll be glad to walk through it. So if you got any questions, please email me or get in touch with me, and I will talk to you soon. Hope you have a wonderful weekend. Enjoy the first week, and we'll get after it again soon. Have a wonderful day.